Hi everyone, happy to be here. As I introduce myself, my name is Adrian. I do cybersecurity things. I also am coming off a little bit of a back end of, I actually wrote and helped found an AI-based static code analysis platform that used, so a lot of the stuff that we're talking about today were the original building blocks of that platform, and so we can get like very in depth about where it goes from here. But this was also originally targeted towards like a group of people that may understand a fair amount about Python, but maybe don't understand a lot about like how large language models function, what the limitations are, other machine learning type things. At the same time, I am not a machine learning engineer, and all of this is like from practical experience. So there may be some controversial opinions from an idiot, but that's totally fine. I default to the actual experts in the group. So we are here to talk about finding vulnerabilities, and we can't really totally start with that until we understand like why it is I'm talking to you about it. So the real quick overview is I have a computer science degree. I was an infantry officer. I did some NSA cyber defense stuff, which is really boring because that's like college stuff back in the day. But then I got out after being a Green Beret, and I was an offensive security tool developer for the government on contract and wrote fun things like that. Then did some defensive consulting, and then AI static code analysis tool. Now I'm the cyber practice lead at a sourcing company, and we do like cybersecurity stuff. Fun facts, lived on a sailboat with my then girlfriend, now wife. I got a spinal fusion. I mentor transition veterans, and I'm a digital nomad, as you can tell from some of the fun pictures. That was in Mexico City and shenanigans. But at the end of the day, like if we're interested about finding vulnerabilities using this, like I wanted to set a little bit of a primer, because at the end of the day, finding vulnerabilities is hard. It is a hard problem to solve. If it was easy, we would not have like as many vulnerabilities out in the world. And so you're really looking for both a vulnerable pattern, but also the exploitability about that. And that's kind of difficult depending on the context, and frankly, it starts crossing boundaries in how testing methods for vulnerabilities actually happen. So you can do dynamic testing, you can do static testing, but the context is super important, but it's also like not important at all depending on the developer that you're talking to. And what I mean by that is like there may be a piece of vulnerable code that is absolutely vulnerable and has a buffer overflow, some type of injection, doesn't matter. But the developer's like, oh, you know what? This code is never actually like, we do all the checking outside of that. Okay, great. I hope it stays that way and no one reuses a function in the future, right? So context can be really important. It is not exploitable, but it might be when your intern comes in and calls that function without the bounds checks that you're originally expecting. So with a deep bug like that, it's really difficult to actually figure out, is it exploitable? Is it vulnerable? As packages move on, actually finding that vulnerable code is also hard. False positives are in a lot of reviews, and a lot of developers talk about false positives, but no one really actually like knows what false positives mean. Does a false positive mean that the code itself is not vulnerable, but it looks like a vulnerable code pattern? Does it mean the vulnerability isn't actually reachable in the current state and the context? Or does it mean that the vulnerability isn't practically usable? For example, if there's like some read-write bug to write to a spot in memory, if you're only really able to do that like one bit at a time, is that helpful? Like it's certainly exploitable, it's certainly vulnerable, but like is that practically something you got to worry about? Well, ask about like processors and things like that, and like some of the vulnerabilities that have come out from race conditions and things like that. So there are also lots of languages, lots of frameworks, even just for JavaScript, right? So like the way that things work in certain frameworks may be vulnerable, but it's also a really high barrier to entry. In the really good scanners, they require a significant amount of configuration up front and a lot of understanding in the code base. And for the really easy to implement vulnerability scanners, they're really generic. It's kind of like Microsoft's like email gateway, right? Like everybody gets spam through Defender because it's terrible because they have to tune it for everyone across the world. But like if you bought something very specially tuned for your environment, it'd be really hard to implement up front, but then you get much better results. So it's at the end of the day, remediation advice is also very finicky, right? Like, so you have a bug, how do I actually fix it? Some developers are great. The intern is probably not, right? That's why you have senior tech leads and things like that. But also the language support tends to be very dependent on what the total addressable market of that language and the pockets of the companies that use it. So C is very hard, but like, frankly, not a lot of people are writing straight C anymore. And so you can't really find good C-based vulnerability scanners. There's SonarQube, there's some other ones, but like, no one actually likes them, we'll say. So all of this like comes together to make things really hard, and no one that I know that has ever written code actually likes their vulnerability scanner for like many different reasons. I see lots of nods and smiles and things like that. So it's a hard problem, but at the end of the day, I wanted to lay some ground rules before we get going. One, don't comment on my code style. It's probably garbage. Also, ChatGPT probably wrote it because a lot of this was pulled out of the usable aspects of a completely separate code base that is production grade and is probably hacked together to get the examples to work specifically for this. It will also require some suspension of disbelief, both from the people that don't understand the limitations or how things work, but also from those that really do, because a lot of things that we ran into when talking to data scientists, machine learning engineers, whatever you want to call them, is that, oh, that's not how that works. You're right, it's not how that works, but for whatever reason, you get an output that finds vulnerabilities. So I don't know what to tell you, right? So it's a complex system. It's hard to predict in general. A lot of this is based on my own experience from 2023 and 2024. GPT-5 just came out. It's actually a little bit of a nightmare for this presentation because they removed all of the previous model access from the GUI, which I was planning on showing different aspects and how different models do it. Turns out I have to do it through the API, so I rewrote all this to run through the API today. So that's how far we've gone. But most challenges still are valid, and we'll show you exactly why those challenges are there, including in GPT-5, okay? Also, don't hate the cyber nerd. I don't like S-bombs. I don't like making your job difficult either. I think developer, as like a former developer, I like get it.
Software bill of materials.
There you go.
What is it?
Software bill of materials. It's like how the government is moving towards continuous authority to operate in certain things, and like, how do you know vulnerabilities? If you deliver a piece of software to somebody, how do they know that the inherent packages that you built on top of are not vulnerable later with those specific versions? So like Log4j is a great example. Everybody freaked the F out, and do we have this specific version in my environment? And no, like everyone's like, I don't know, like how many pieces of software do we have running on our servers that might be using this? It's pretty prevalent.
So it's a big manifest of like every piece of software in your system.
Yeah, it's also the answer for like a lot of cyber people are like, oh, do S-bombs for everything. And then from a developer's perspective, the answer is like, why would I do that? You like, how much of this package am I actually using? How much are we also like raising the red flag that this package is vulnerable, but it's like something we're not even using type thing. So like there's a, if you know it, I guess I've reached the too deep joke. That was perfect.
How far does it go with transitive dependencies to?
All the way.
Yeah.
All the way. So, traditional methods. If you're a developer, you've probably seen these before or you've been pitched them. There's really two different types. There's static testing and there's dynamic testing. This is important to know. Static testing is usually run on source code or decompiled code. Less frequently there, but anyway. There are different approaches in that engine, and this is important to what we're going to talk about later, but they're either comparing your code against a known good pattern, or they're comparing your code against a known bad pattern and then trying to match and figure out similarity, or they're doing straight up regular expressions for one of those two, which is a nightmare for literally every person that's ever had to do it. Sneak, SonarQube, Black Duck, probably seen the names. Dynamic application security testing is really more focused on the code is running somehow and you're fuzzing. It's like a specific technique, but you're jamming in inputs to trigger unexpected behavior that the developer originally didn't anticipate. And you're testing a lot more code paths, but you're also not necessarily testing a lot of the same things that would be triggered in a static code analysis. So ideally, products in the market will do one or the other, and you have that in your pipeline, and you don't have to and then your pipeline doesn't pass, and you have to figure it out, rewrite your tests, all those other types of things. I do have XKCD comics throughout. Feel free to giggle. So where I started was, let's take an LLM. We all saw LLMs come out, and we're like, okay, well, these are trained on large amounts of data. The specific LLM that you're using might be trained on code data. Maybe that code is good, maybe it's bad, maybe it knows what a buffer overflow is, maybe it doesn't. But now that we're at 4.0, 5 mini, all this other stuff, a lot of the inherent stuff is in there. But how far can you get just taking a file and throwing it into ChatGPT and be like, tell me what kind of vulnerabilities are in there? So surprisingly, it's actually pretty good. And that's why, let's just pull up ChatGPT. You'll see lots of stuff here. So I'll just kind of do the most obvious search first and pull one of these files up. Ignore all the output. That was the backup just in case the internet wasn't working. But we have a couple of different example files here, and I'm going to pick C because I figured no one here would actually know what is actually in the files. But also, it's really hard because C has direct access to memory. You can write, you can read, you can allocate it manually. As a result, the code is a lot more complex, and the types of bugs that are available are also a lot more complex. So we have a deliberately vulnerable program here that actually very clearly spells out where these vulnerabilities are in comments. So there's an integer overflow here that has to do with let's say you take two numbers, you add it in there. In this particular case, the actual integer size that is allocated in C, depending on your operating system, can be added together with those two numbers that are below the maximum amount. And when you add them together, it actually overflows in the bits, and you end up rolling over the 1111111 into 00000, and it keeps adding. Okay? And so that ends up in a value that you don't particularly want. Now, what happens if that's a memory pointer? Well, now you're accessing some other piece of memory, things like that. Okay? So all that to say, we've got a heap buffer overflow, use after free, integer underflow there. So there's a lot of different bugs in here, and this is written specifically to do that. I did take no comments, and I removed them because it very clearly spells out where the bugs are, and LLMs are actually kind of good, right? So there is a little bit of inherent bias that's going to come up in here because, frankly, ChatGPT has probably indexed this file in the public space before. But let's just do something silly. Tell me if this code is vulnerable. Vulnerable. Just dump it in there. We hit go, right? So it's going to think about stuff. Now, imagine the timing here, because timing is something that we're going to get into our discussions as we move forward. It's doing it's decided to do agentic for whatever reason. I probably could have turned that off, but it's deciding how long to think. Looks like there's some problem with network input treated as integers. Code has a few serious issues. So all this is going on, right? Now, you're a developer. This is not a big file. This C file does very little. It opens a socket, and then it just listens to things, and then it'll close the socket. It does some basic pointer or some basic arithmetic for allocating stuff. But is this a sustainable method? Probably not. So while that goes, I actually rewrote an example here. So we're going to cover real quick what is happening. It's pretty easy. Here's my OpenAI key. Don't copy it. I'm going to roll it. Don't worry. I made a specific one.
So one question on that, what was running before. It was saying it's looking for memory issues. Is it looking for a certain class of issues?
So this is just, I let ChatGPT run wild, right? So if you haven't seen ChatGPT 5.0 or 3.0 when it came out before, it's more agentic. It's basically behind the scenes taking this and breaking it into sub prompts and then using different prompts themselves to both figure out what additional actions it needs, but also like, is this correct? Is there other things I should consider? And so it's like spider webbing out all the stuff in the background. So it's pretty cool. But if you're running one LLM and one engine in a single thread, you're not going to get this. You're going to get the fast response that's based entirely off the training data. So, okay. So this found a lot of vulnerabilities while it's going, right? So like big issues, blah, 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 size. Here's some examples. We'll just take numbers, right? We don't have to get into it. 8, there's a memory leak in certain things. How to make it safe. Did we ask it to make it safe? No, we did not. Did we ask for all of this? General rules? No. Right? So it's great, but if we're in a environment where we actually like want it to do the thing that we ask it to do, which we kind of start moving towards, it's a little bit less ideal. If you're running one file through, you're a bug hunter, you're a software developer, you're like, hey, what kind of vulnerabilities exist in this code? It might help you, but how much do you want to throw your proprietary code into ChatGPT? Probably not a lot, unless you're on the enterprise plan or an OpenAI endpoint or an Azure endpoint. At the same time, what you can do very easily in Python is just use the OpenAI package and set your API key. You do have to configure like the models and you have to like pull the API key, but very easily, a lot of this is just set up for this particular call. OpenAI client, chat completions create. We give it a prompt for the system. You're a helpful assistant.
Zoom a bit.
What's that?
Zoom a bit.
Oh yeah.
Make it a little bit.
I forget how to do it on my Mac. What is it?
And
Command Shift plus.
Command plus.
I'm just gonna Command plus. Perfect. Ooh, that's a lot. How's that? Is that better? Not as good? We'll do more.
Is there a resolution
That's
of the monitor?
That's good. That's it.
That works. That is a little.
Okay. You can see this in the back? Okay, great. So it's really there. It's based into a system prompt and then a actual like prompt for the content. And what's happening kind of for Python use is that you can chain calls or provide it memory that it would normally have in the like the ChatGPT chatbot interface and provide it more context that might be helpful for either referencing data or allowing it to like know about previous conversations. I also want to bring up this went away in GPT-5, which is enraging, but so there's this thing called a temperature. And the temperature is something that most people that have used an LLM like haven't worked with unless you're using the API. And it has to do with how creative the LLM is going to be in its response. And so you can crank it up and say, I want you to be like really, really creative, right? Like just crank it up to 11. And then it's going to start spitting out unicorns and fun things and just be really off the wall. Sometimes it's helpful, sometimes it's not.
Hallucination dial.
Yes. And so, or you can tune it all the way back and give it very specific instructions to like 0, right? And say, oh, if you don't know, just say, I don't know. That's fine. And then it will have less likelihood of hallucinating. At the end of the day, we'll just run it real quick. This is unchunked because we'll get there eventually, but you saw how long it took for the agentic side. Well, this is still running in the background, but we don't really need that now. But let's just run just our simple text here. So this is going to call, I think, just GPT-5. Okay, so it's the same model, it's just the not the agentic side. And so we'll start, there is a timer built in, so we will see how long it takes to analyze that file, okay? Actually want to trim that slightly so we can save time. We don't really care about this one because we only really care about the non-comments because everything else is just gravy. So we'll run it. ChatGPT 5, not super fast, right? So while that's rolling,
does it penalize you every time you pass query? Is it looking at your load?
At my API calls?
Yeah, through the keys.
It can. Throttling actually only really happens when you're like breaking the true OpenAI like requests per second or a average request per minute, which is really enraging. So you need like, if you're going to do this for like real, you need like fallback connection trying or other API keys, or use the, so one thing that is actually really helpful if you wanted to build this type of stuff is get an Azure account and run the OpenAI LLM endpoints in Azure, because those are subject to the Azure Enterprise privacy policy, which doesn't retrain, doesn't store, and only keeps it for 30 days for like abuse, like nuclear weapons, child pornography, other sensitive type stuff. So if any of you are looking to implement that over time.
It's HIPAA approved as well.
Boom. Thank you. So that took 75 seconds to analyze one file.
How many lines is it?
It is, tree socket 137. So, and it's super low, right? So like what's interesting about C is that LLMs in general count symbols differently than we view them, and they count based off tokens, and tokens can be basically, it's like 4 characters or a piece of punctuation. And so you're incentivized to have small variable names, but at the end of the day in code, it doesn't really matter because you've got brackets, you've got all kinds of signs, you've got all kinds of other stuff that really fills it up more. But let's take a look at what actually came out and how it gave us that 17, is this us? 1943, it looks like us. So this is just the raw dump. Yes, there are issues, memory safety, blah, blah, blah. Didn't number them, there's a memory leak. It's very similar to the output that came out to us, except we didn't see any of the thinking. So in the behind the scenes, it may have done that same agentic call. But at the end of the day, like this isn't super kind of helpful. And the reason why is they're talking about endianness and host interpretation, and this might be a problem, but it's probably not. Like, because that's not something that you would normally need to worry about in how you would actually implement transition, like sending data, but it's kind of false flagging that for us. So we're also getting some division by 0, great out of bounds reads, but it's from like a vulnerability hunter. Like if you had written this, put it that way, you're a developer, you had written this, and the security team hands you this output. Like, is that helpful for you as a developer? Like it's probably a little bit less helpful. And so how do we refine this to get it to better identify vulnerabilities and better produce output that's consistent and actually finds these things? Well, funny you should ask. So let's talk quickly about what just happened and like why this is not super helpful. What we don't see is the false positive conversation. Hallucinations are really, really, really prevalent the longer the context window is used. And so if you have a large file, it is more likely that you are going to have a hallucination in the actual reporting. And that might just be something like it says it's a buffer overflow, but it's not. It's like clearly doing a bounds check right before it. But because you have so much context and it's trying to process so much in a complex, like finding vulnerabilities is hard, it's gonna freak out a little bit behind the scenes, and it's just gonna like shorten the pathways and whatever linear algebra is happening behind the scenes, and it's going to give you wrong answers. At the same time, there are also vulnerabilities that are in this that are not being called out specifically. You're gonna have to trust me, it's there. But if it's not here, you're going to run into it when you use this same technique for other things, because it doesn't really know what a vulnerability is. It's only really matching patterns. The time taken per file is like unsustainable for any large code base. If you wanted to build this yourself, you wouldn't want to kick this off overnight. Like even because how big is your code base? Like I hope it doesn't have an error. I hope you don't like get some gross output, and then you have to parse through all those files individually anyway. Like that sounds like a nightmare. Also, I bring up cost because it's small here, but cost is like a pretty big problem, because as you start getting into more advanced or larger code bases, Like, yes, this has a 200,000 token context window, but input and output tokens vary based off how expensive they are. And you can very, very, very quickly, ask me how I know, run through cost. Did I get $25,000 of Azure credits and burn through them in one night when my co-founder tried to scan the entire JavaScript core library, except there was a minor error in how we were doing things, and it ended up in this loop where I should have implemented a dead letter queue and didn't, and so all the errors kept retrying? Yes, that happened, right? So like, you can rack up costs not just by making the calls themselves, but by errors, by troubleshooting, by testing, and you run into problems like pretty quickly. So O4 Mini is actually like a pretty affordable model. As you get into the rest of the pricing, I'll highlight that again. 4.0 Mini right here, this is the line that we just looked at. And this is by far the most affordable input per 100,000 million tokens, whatever it is, compared to some of the other ones, right? You want the latest ChatGPT 5.0 or 5, it's $1.25 per million. Output is $10. So the more output, the more vulnerabilities you have, the more cost is going to start driving. Does that matter for you if you're only scanning a small code base? Probably not. If you're implementing like...
What is that output per?
I think it's per million still.
Okay.
Output per million tokens. Yep. That's how they usually price them. So it's still a lot, right? Some of the other ones are like 4, 5, or at least they used to be 2023, 2024, right? Like back in the day of LLMs like 2 years ago. Processing power is like a problem. No matter what you do, like it's just kind of like a problem you're going to run into.
So for those tokens, for all of the extra information you said you may not really need, you're paying for that too as
Yep.
part of it.
Yep. And so another issue is formatting, right? Like take a look at the output here that we just showed, and like it's not super helpful from a, like, show me the vulnerable code. Do I have to search for every time the image data variable is used? Like, I sure hope not, because that struct is used a lot. Now you imagine like a Python file where they call out one variable name and it just happens to be like, I don't know, like a struct or a pointer or something like that. Like you're gonna have a hard time. So we wanna refine this, which is why we get to a little bit more of like, how do we do that? Well, first we'll talk why. Then we won't talk about this again. LLMs only know what they're trained on. I think we all know that, right? But it also kind of works based off probability, and that's how it's predicting the next character and token and stuff. And so like, if the code base is trained on really good code, then it might not be catching vulnerabilities because it just assumes internally with its pathways that like bad code is not as big of a deal. Whereas if it's trained exclusively or fine-tuned on bad code, it may be finding much better stuff. But how do you retrain a model on new vulnerabilities as they come out? Like, that sucks, right? You got to retrain this whole thing? Like, no thank you. So how can we do it? Let's start like refining our process a little bit more. Oh yeah, that's actually thank you, presentation. It's also not actually analyzing anything, right? Like it's taking the text that it has and it's just predicting output based off some inherent pathway that's happening. It's not analyzing any of your code. It's not. And so what we think is happening and we think it's finding these vulnerabilities is just a text predictive engine. So it's hard to go back and understand and not predict, but like recreate some of the same problems or vulnerabilities when you go back and test it on the back end to prove it. Context windows, I mentioned briefly, but context windows, when you use a large context window, the fine-grained nature and accuracy falls off. It just does. Or you can pay for a much higher fidelity model that takes a longer period of time and is more expensive to run through and predict things, which is what GPT-5 was doing in the background. So how do we do it? And got excited. So if we think about the problems that we just had, we gave it a really vague prompt. We also had the temperature of the API call. Do we want it to be creative or no? If it's creative, it could find more creative bugs based off other historical bugs that it has in its training, or it could not. And it could be like just coming up with rainbows and unicorns and prone to hallucinations. But what if we run out of context window for a big file? What happens to the rest of the bits, right? It just drops it and we're only analyzing half a file, a quarter of a file. What if there's lots of vulnerabilities and we reach the actual output window limitation? Or we end up spending a boatload of money on the output tokens because they're $10 or whatever, but like you run out of that pretty quickly. What if your security tool output, what did I say there? What if your security tool, like if you wrote this and it output an individual file with vulnerabilities for every single one of your files in your code base? Like it would not be helpful, right? So we can't solve all this immediately. Instead, let's take a look at prompts. So you're a very helpful cybersecurity expert that developers love. Do not let them bully you into believing that you provide no value, right? So that's example 2, and I'm going to walk you through kind of what I did with this. We'll close these guys. So example 2 is an example of like, how do you actually prompt with system, and how do you prompt with the actual like prompt for the content? So in this case, we're going to say, your name is Dixie Flatline, and you'll only answer questions about cybersecurity. That way, if someone dumps a file in here that's a picture or some other random text, a love note to their wife, then it's not like I only care about cybersecurity bugs. Take your time, follow instructions. Quality of your analysis is important. Accuracy matters. Avoid language constructs that could be interpreted as expressing remorse, apology, regret. This includes any phrases containing words like sorry, apologies, regret, even when used in a context that isn't expressing remorse or apology or regret. If events or information are beyond your scope or knowledge, provide a response stating, I don't know, without elaborating on why. The information is unavailable. Refrain from disclaimers about you not being a professional or expert. Do not add ethical or moral viewpoints in your answers. Keep responses unique and free of repetition. Never suggest seeking information from elsewhere. Why is it so big? Because those are all problems that I faced in writing this originally. It always wants to elucidate and be really smart and tell you much more information, but no, we don't want that. We only want the vulnerabilities, we want the code snippets. That being said, for the instructions prompt, let's give it some guardrails. Let's tell it how to format this stuff. You're going to give it source code, review it, respond in this general report format for each bug found. Vulnerability class, categorize it, I don't care. Use your best judgment. Provide a summary. Also provide the code snippet. Surround it with some 3 dots. That way Markdown could work. Blah, blah, blah. Everything else is the same. Except we can change the model type based off of, so I've added it in 2 different models. So we can see the difference between GPT-5 and GPT-4o Mini, because GPT-4o Mini is a little bit more affordable. And so we're just giving it that same thing, the instructions prompt, and then just dumping the file contents into it. Okay, so not many changes. Let's let it rock and talk about what is going on. So, based off your thoughts, your experiments, your own intuition, how far do you think this is going to take us? Thumbs up? Best output ever? Shout it out.
It'll be better.
Better? Okay.
What existing tools would you use if you weren't using LLMs?
For like static code analysis?
Yeah, and how can you compare the 2?
Someone else's scanner. Sneak, SendGrep.
I'm gonna guess it's gonna be extremely verbose.
Okay.
I'm gonna guess it's gonna produce a bunch of maybe it has this, maybe it has this.
Interesting. Okay.
As long as you're armed.
I have definitely faced that. And like it comes out and says a lot of information that is not, frankly.
When you told it to format it, it will come out with a very long, carefully formatted list.
Yep.
Let's see.
Let's see.
It'll be 20% better.
20% better. I love that. Okay.
Because there's 5 examples.
There are 5 examples. I will say, example number 5, not going to run. I didn't get there. But that involves a RAG pipeline, vector search, and matching source data for stuff like that. So that's like, it's awesome. It also works really well. But like, that's where we're going.
Yeah. You're paying by the words, so have you ever tried telling it to use as few words as possible?
Yes.
And did it listen?
No. And there's some inherent reasons why, right? Go ahead.
Yeah, I've used Copilot, the Copilot plugin in VS Code, and instead of doing this Python kind of writing thing, and it can do a lot of this stuff. I know you used it on vulnerability. I've used it for just for regular debugging. Would you use it as a vulnerability scanner?
No.
No,
I
not
would
up
not.
to it.
Nope.
Okay.
And we'll get into why when this is done.
Okay.
And so if it might not, well, it's still processing, still running GPT-5, right? Still running that same GPT-5 call with those instructions. So like not super helpful, I would say, but let's take a look at.
But it doesn't know what helpful is.
It does not.
We've given it no context. We've
Correct.
Just said, look at this file.
And so let's do.
I have a question. Independent of what you're illustrating, does the OpenAI library or whatever you're using, does it allow parallel running? Like, could you spawn off?
OpenAI does not, but you can. Yes, you can. Well, yes.
LangChain or some other tool? Yeah, because I know those things support more of that, I guess.
So I'll jump ahead
Yeah.
in the lessons learned side, right? Like, so when I started this originally, I used LangChain, and I lasted probably 3 days. Because what ended up happening at the time was a disconnect between the package and how that is being maintained and the API calls and structure that OpenAI at the time was building. And so it's kind of, now it's a little bit more stabilized, but what LangChain wasn't doing was appropriately retrying on timeouts, and it wasn't doing the error handling that actually allows you to detect when something goes wrong. And so what I want to do is like, what was the response? What was the response code? Was it like an error? Is it an internal server error? Am I authorized? So I have to figure out like how am I actually like doing this from a production standpoint? And so actually we ended up like kind of running to like requests, and I was just hitting the API directly and then pulling it off manually, which was the most stable way to do it and also kind of the fastest. Processing file still. Oh, now it's going on 4.0 mini. Okay, so we got at least 5 done. See which one of these. And so 4.0 took 13 seconds, and GPT-5 took 101 seconds. And so, okay, let's check out 1958. Is this? I am mislabeled things. Where we're at 1958. Yeah. So when we take a look at this, 4.0 did a great job. This actually might be, yeah. 4.0 did a great job, and it's actually doing all the things that we wanted. We get a little bit of the code snippet here. Segment accesses buff1 after it's been free, the condition, blah, 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 blah. But let's check out.
That was your one with comments. You got, I think you ran both your comments file and no comments file. That's part of why it took longer.
Oh, did I didn't comment it out?
So I got the no comments ones above, have both the 4.0 and the 5 there.
2000, perfect, thank you. So this is 4.0 mini. We kind of got some of the, well, we got some of these jammed together. We'll say it that way, right? Ideally what we want is it's separated by equal signs so that we can parse it out in normal Python shenanigans. But here there's like 3 vulnerabilities that are all kind of jammed together. So we tried. Then there's a memory leak. We got some more. Maybe it's listing out multiple memory leaks, but in this case there's only like 2. Right? So we've got a buffer overflow that happens a couple times and a memory leak, which is not all of the bugs, like period. And so when you take a look at 5, no comments, does that do any better? Does better a little bit, but skips out on the formatting. We get more, but it also took 101 seconds, right? This might have caught them all. No pointer dereference. Yeah.
You also have to pay more for all of the false negatives and false positives.
You do.
All the false positives.
You do.
How confident are you that the code snippets are even out of the...
Great question. We aren't. So we have to go back now, right, and figure out like, okay, if this is part of this, like, do we search for this specific thing and try to locate it? Like, what? It would be great if we could have like a file or a line number. That's actually harder than you would think.
A line number?
Yeah.
I think he wants to provide that.
So we'll say ChatGPT 5, pretty good. Took a long effing time, right? Found a lot of stuff. we're still not like probably totally sure, but it's like not a sustainable way to like have it. It also kind of messed up all the formatting. So if we want to parse this, our options are probably like, well, find the new line, find vuln class and split it out. And I hope that it doesn't somehow change with a new GPT-5 model and suddenly change the format in the middle of like our deployment when we've gotten the script written, right? So let's quickly chat about number 2, right? So I kind of guessed what was going to happen, but it's better, but the formatting's still not great. I pre-wrote this. Even with the example being put in, it didn't action all the examples or all the format stuff. And we can't consistently parse that out. Did we ask for what to do better? I don't know what I was trying to say there. Just forget it. But as we add more complexity, what's happening is we're now trying to have it format a specific way and find vulnerabilities in code and explain what those vulnerabilities are, and it's too much. And so even with a really advanced model like GPT-5, it's not sustainable and it's not like reproducible and it's not going to be able to do all the things that we want. So we're also paying the time cost for LLM processing power, and it's not scalable at all. We're still limited by what the LLM actually knows in the training data. And so we're limited by the model capabilities. And as the number of and complexity of the vulnerabilities increase, hallucinations increase. So as you're looking at that list, the number of ones that are not actually vulnerabilities, but it like thinks it is going to increase and is going to keep wasting your time. So the time difference is also massive, but at this point, like we probably for this demonstration, we're going to strip out GPT-5 and just stick to 4.0 mini because it's like probably good enough, but we're going to start getting, how can we get some of the accuracy from like a really expensive model and break it down into a less expensive model.
Did 5 have a comparable smaller model, like Nano or something like that?
It does, and it does okay, but it still takes a long time.
Okay.
Not nearly as long, but we'll see. What we're really like shooting for, well, I think it's in here. Yeah. So what we're trying to shoot for is the perfect balance between accuracy, speed, and cost, both in processing power and like dollars. And if you're gonna scan a whole code base and you actually care about this, then you kind of need all 3, right? And so like that just means that you have to compromise somewhere else. But we need specifically vulnerabilities to be accurate, and we need it to be scalable in time. The cost is going to have to come like we can't use GPT-5. That's the bottom line, right? I think we've talked about this and beat this to death. So what did I go next? It's chunking. And so sounds like some AI bullshit, right? So the real answer to this is, what are LLMs good at? They're good at summarizing, and they're good at like reasoning at like a small level, because the reasoning at that point is predictive text still. But there's enough like Reddit data or Stack Overflow or something like that to like solve one problem at a time. So if we can chunk our source data and bring that down from a full file, we eliminate some of the problems that we've been having. Specifically around like, it does introduce new problems, specifically around like processing time, overall cost a little bit, but also like some of the complexity. So we can get accuracy and formatting a lot better if we're using a chunking algorithm. And so I will just, yeah, we did some of these, no comments, great. So we'll probably only just do one of these, but how did we chunk? I did it in the dumbest way possible. Take a file, take a number of characters and slice it off, make a list, and then for each one of those chunks, send the same LLM call that we were sending before. Now, at the end of the day, that sounds cool, but now we have however many chunks with that many like vulnerabilities in it, right? So like now we got to cram them all together. There's additional problems with this, but let's very easily, like it's a chunk list, right? It's pretty obvious. Front index, chunk amount, I just picked 500. This is tunable based off your language, based off the model, based off like your environment. So there's another complexity piece. If the file length is too long, just, you know, as long as we're not like, if the file length is less than 500 characters, just run it once. Otherwise, like do the chunking thing. And so we'll add a little bit of processing the file. Oh yeah, let's chunk. and call it in. And we'll just do, I think, just one model here. We'll do, just make, yeah, so GPT-4o mini. And we'll see how long it takes. UV, run. Thanks for that, by the way.
You're welcome.
So I did put some text in so we actually kind of know what's happening. It's decided that this file is 6 chunks. So just based off the number of characters, it's processing. While it's doing that, how do we feel about this? What other problems are there?
I can't imagine a client that would accept an LLM as a tool for cybersecurity.
Okay, why?
Where's the liability? Like, what if there's a vulnerability that the LLM didn't find it?
This is a great conversation to have. Okay, what is the difference between that and Sneak?
I don't know. I don't know. But I'm sure you must have insurance or to.
I mean, there's cyber insurance, but that's usually post breach.
Well, I guess what I'm
Yeah,
yeah. Go ahead.
Well,
I was going to say, I would kind of twist this around a little bit. He's saying that you're putting a lot of trust in GPT-5 or GPT-4's knowledge of cybersecurity, but they're also optimized over a broad set of topics and input, which could compromise some of the information they believe to be true about cybersecurity. So it's not really a model that was targeting cybersecurity. It's a model that was like, incorporating that with a mass corpus of other knowledge and information.
Uh-huh.
Yeah, like
So even the answers you get and the prompts you use and the methods you try to ask questions may not ever get you the answer you want because there's limits to the model itself.
Yes, agree.
So as far as like a client paying for this, I will say that my company has a sort of similar situation. We're a healthcare company, so we're not cybersecurity, but we're providing answers to contract data that people need, and at the end of the day, it gets used to make decisions that can cost money or get you in legal trouble. And so it is a really big, annoyance. And there's a lot of things that can happen where customers get really upset when answers aren't correct. But at the end of the day, it's just so darn useful, and if treated well and sold with the right mindset of like, this is AI, it's not foolproof. This is the percent. We track like what percent each of our things is likely to be correct. We give them that number, so we say like, for this particular question, it's going to be correct 80% of the time. This one is like 90, we're like 90 to 95% of the time. So like, you have to be really transparent about what this is and what this isn't. But yeah, at the end of the day, clients will still pay a ton of money for this stuff because it's so helpful. So
I think the thing that I might layer in there is when I'm thinking about it, like why does my team care about vulnerabilities? It's because our business cares about our risk profile. And there's a cost trade-off between how much risk are we willing to accept, because we recognize that no amount of scanning is going to potentially guarantee, short of doing formal proofs, like formal code proof stuff, which basically nobody in our industry does. How do we have confidence that we've worked out all the bugs or worked out all the vulnerabilities? And the answer can never be we'll be 100% confident. So it's can we get close to that number at the most reasonable cost? That's the trade-off we're working through. So if AI is finding the real most likely category bugs that it's we left a buffer overflow there or something along those lines that are the kind of the bread and butter of hackers taking advantage of software, then that seems like a win to me. So that's my
I think a lot of use just comes down to money. I mean, it doesn't matter what your use is, whether it's cybersecurity or whether you're trying to replace a call center. It's what is the cost benefit. So, and it's bad because a good example is the other day I called made a customer service call to a bank. I got 10 minutes to run around and a bunch of transfers while the automated prompts. And then I finally got to a real person who transferred me to another person, who transferred me to another person, who transferred me to another person. So which of those is better?
Yeah.
Well, probably neither. Which one was more cost effective?
I was going to say, it's all about risk mitigation, and early last year, the director of Cybersecurity Information Systems Agency, CISA, she testified to Congress, and she said none of the companies are even doing the most
No, they're
basic
not.
stuff
I mean,
to protect our
don't
system.
even get me on start on that one. Okay, so I'm gonna reel us back in. We're gonna take a look at this. So just quick overview after you scan through. I know we were talking. There's some formatting issues, right? There's some stuff, but we're probably closer. But what it kind of like lost its mind still a little bit, and that's because we're using like a less helpful model, right? Like we now have to like, if we don't want it to take 150 seconds to run this file, we have to drop back to a model that is like not as good. And so it just doesn't have as good of a training. It doesn't have as good fidelity in detecting vulnerabilities. GPT-5 would be amazing if we could just run through that all the time, but it's just cost prohibitive in lots of different metrics. And so what we actually want to try to do is use the best model that we can within our constraints and then bolster that with traditional ML, AI, programming, like whatever those things are, because we've already just talked about it. Like an LLM is not going to be able to do the same level of analysis and detection holistically across a file. At the current state, it just can't. Where it can help, let's just see what I had written down in my thoughts here. So at the end of the day review, we chunked, we cut it up into 500 character sections, and then we just ran it through. So it probably missed some stuff because like there's a couple of fundamental issues with how we just did that. Formatting's, well, I lost that one. It was not much better. But we run the risk of missing vulnerabilities that are on top of the chunk cut. Which like, that's not great, right? So like, what we can either chunk it bigger or we can chunk it smaller, but how do you figure out that line? Like between like, how do I know that that wasn't the middle line between the vulnerability where the buffer overflow was? Or where that is checked for the bounds constraints and it like shouldn't be even reported at all.
And there
Would you
there are
double
now-
chunk it?
There are SaaS companies that are dedicated solely to the problem of chunking now.
Yes.
So this is such an important question that like how you chunk your thing, because it's like, oh, well, you want to make sure that you put all this together and you don't split your paragraph in half or your page in half. And like you have multiple pages, multiple files. How do you combine it? It's a nightmare.
So how do you approach it?
I'm getting
And so
stressed.
this is a really important point that I wanted to bring up like right at this moment, which is we're moving away from, well, does it sound meaner than I mean it, but we are, as engineers, hindered by our knowledge and our desire to understand the problem and understand like all aspects of the solution and be clever. And what we should be doing is exactly what I did in the next example. You double chunk it. Because at the end of the day, do we want to figure out where the best process to split this thing is when all we really care about is find me the vulnerable sections of code? That's it. That's all we really care about at the end of the day. You would love to know a summary and a description of the file and all this other shit, but like at the end of the day, what do we need to know? What the actual vulnerability is. So is there a balance between speed of knowledge still limited by the LLM training? How can we bump up the knowledge of the LLM while keeping performance speed? And it's a little bit hard, and I kind of wrote this separately. This should be try 4, but we're gonna overlap the chunks and we're just gonna make an additional LLM call. Because what are LLMs actually good at? Filtering through text and identifying like generic text patterns. So like, okay, let's chunk everything. What I'm gonna show you, and I'm gonna show you like conceptually first. Conceptually, imagine the window, right? Like It's just the window problem in computer science. If you have this entire wall being the actual code lengths, lines sticking up, we're going to start with a window here, and then we're just going to take it out and put it halfway and move it there. And then this is our new chunk. And then we'll take it out and then move down line and boop, we'll just do it again. Now, the obvious problems are like, well, if it was slow originally, it's going to be slower now because we have like, what, 1.6 or 1.8, the number of chunks or whatever the math fractorial things work out to be. But like, do we care if we're using a dumb model? I don't know. Let's kind of see.
Well, and it also assumes that the vulnerability is within the chunk window.
Yeah.
Because the code could span one chunk, and then that makes the vulnerability.
Right. So how big do you chunk it?
Yeah.
How big are vulnerabilities?
That's how big your function is.
Makes
It
me,
depends on, like, they could have declared a variable here and then used it at the bottom.
Or multiple
screw that.
files.
Where did you free it, right? Yeah. So I'm so glad you guys are.
I mean, you let off with this is hard, right? So
Absolutely. I gotta remember which one. I think it's this one. That's what we actually want to go to. So you're absolutely right, and it's so hard because what I did was I just randomly took these bits, right? And so from a Python perspective, it's pretty obvious, right? We're just doing the sliding window across the board. We add the actual window amount to the front and the back until it hits the end. And frankly, because when we actually slice things, the back index, if that value is too big, it doesn't really matter. It just stops at the end of the line and just gives us the data back. So this is cool, but then we have a bunch of potentially duplicate bugs, because if we have a big chunk, because we think that, well, someone said we declared a variable up top and then we use it down below, and that's like we freed it, we allocated the memory up here, and then we used it or did something wonky down here, like how big is that chunk? Well, I don't know. Like, how big is your function, your code? Like, do you want to optimize it based off your function? How big are your functions, like, consistent across your code base for size?
could you put something in the code saying start chunk here? And, I'm thinking like a try catch block.
Yeah.
For LLM.
And that goes back to the original problem. The ones that are the best and most accurate for your code base, for code scanners in general, require a lot of upfront configuration and context. And so you need to insert those, like whether it's stack canaries or things like that that are inherent in those packages, or like if you're writing it into your application, then I know that I need to chunk at these particular sections. Well, how maintainable is your code base at that point? If you ever switch to another code scanner, another methodology, you got to go back through and like, yeah, find replace is easy, but.
I assume that traditional tools can do things like extract functions and classes. Just because, like, I'm thinking like Git has done stuff like that for a long time.
Yeah.
So.
And I mean, frankly, your code editor does it, right? Like you can just do you can do it by indentation, you can do all. So, but think about the complexity of the LLM now. Hey, I'm gonna chunk, I have to write a Python chunking algorithm that works on my code base that is going to break things up in functions, but what if it's just a primitive? So like, what if you're searching for a deserialization error? That is like, frankly, that's what log4j was. It's just poorly deserializing data. Like, how many people looked at that code originally and thought it was fine before it was like, oh, it turns out the whole world's gonna melt. So one of the concepts that we kind of honed in on when we were originally building this product is like, you need to ideally search for bug primitives. You shouldn't be using the LLM to find, hey, show me these vulnerabilities. What you should be doing is identifying the types of vulnerabilities that are in your code based off the type of actual language that you're writing, and then find those primitive patterns, right? And so if you can ask an LLM, find me a buffer overflow, and a buffer overflow looks like this, and you have 10 examples of buffer overflows, now the LLM has a much better understand, because now it's not looking for code. It's not. It's actually just doing text matching. And it's doing what LLMs do best, which is just that predictive piece, because you gave it all the source data. Yeah.
So, maybe I'm, jumping the gun. So, I'm not super familiar with, like, how to spot, like, vulnerabilities and like, whether or not you can look at a single line and say that's a vulnerability versus needing to, like, piece together all these things.
Mhm.
But what it sounds like you're leading to is taking a traditional tool that will find things that are likely going to have a bunch of false positives, and like crank it up to like find me anything that could possibly look like a bug, and then pass that into the LLM and say, hey, does this actually look like a bug?
Whoa. Whoa. Wild.
Is that what you were about to say?
We're getting there.
All right.
So we just went on a 1.5-year journey in your brain right there. And so we'll take a look at this. Yeah, we chunk things. Yeah, we use a rolling window. Deduplicate results is stupid. It's literally just deduplicate the following results and do nothing else. By deduplicate, I mean identifying the same discovered vulnerability and leave just one. Include all the rest of the information in formatting. Do not add any additional text. I had to write that prompt today based off of the bunk output that came out just from GPT-5, because it was, I think one of the results was the ChatGPT equivalent of go F yourself, which was like, I don't know how to do deep, like, you need to tell me what deduplicate means. I was like, okay, just shorted you out, I guess. But we'll skip actually running it because we have both of them here. But this is the duplicate code, or this is what ran with duplicates, and this is, it's probably my code here. Oh, there we go. Okay. So I had a problem with actually adding in the deduplication, right? Like, you saw the deduplication script. It's the same call. It takes that data, it takes this data and this text and just throws it into another call and says, hey, deduplicate any of these entries that might be prevalent. It comes out like this. Vuln class, potential, stack, buffer overflow, blah, 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 blah. How big are we going?
Perfect.
We're going pretty big. Just assume it's fucked up. So, like, that's 4.0, right? So 4.0 mini, just, I don't know why it did that. Maybe there's some encoding error that came back. But, like, it's a complex system, and we just added another complex thing for an LLM to do. And debugging this now is, like, a nightmare, because unfortunately LLMs are, like, not determinate. So you can't, like, reproduce this consistently every time or know specifically what the problem is. So, did it find everything? Maybe. No, it didn't. We'll say that. So it stops, I think it was at 5. But the format is, like, way better now, because all we're essentially doing is giving it one task and having it do that one specific task in this piece. And so then we get into the true kind of like next level shenanigans, which is like what just happened. It was usable output with limitations, probably, right? So like it missed stuff. It still isn't totally parsable, but it's better than when we started. This is also, like I pointed out, it's single threaded. And so it's entirely IO based. It's waiting the entire time for the LLM to process that. And so you can get massive efficiency improvements through chunks for a file just by threading, right? And so threading is like, or you can like really delve into the hell of Python and go async IO and just like rewrite things every time the new version comes out. But like, there are ways to get around that. And that was what we did, is we ended up threading and threading and threading a lot of stuff. And that's fine, because like you just end up doing lots of calls for lots of chunks for lots of small problems, but there is a better way to do it. Yeah.
I have a question. You had the LLM perform the deduplication. Couldn't I mean, I haven't looked closely at what you're doing. Couldn't you do the deduplication yourself if you captured each of the outputs as a thing, put it in a sentence transformer, and like did a k-means clustering, and you're like, hey, these are the same thing, these are the same thing, these are the same thing.
Yes.
Okay.
And you know what else you can do?
What else?
We'll get into it.
Okay.
So let's talk about what the next level is. So outside the scope of this discussion, that we'll just like very quickly baseline, right, is retrieval augmented generation pipeline with similarity search based off of a actual source data set that is vulnerable code, that is known bad, that you can assemble, you can create, you can do it however you want, right? That's another challenge. That by itself is another challenge, but we'll get into it in a minute. But essentially, by breaking the chunks into whatever you think, whatever your code snippets and your source data known bad is, you can do a quick similarity search on the chunk and do a quick vectorization, right? Just do a vector, compute it for the source of have it all pre-worked out and do a vector database search based off the new vector that you just vectorized. So for those that don't know, I'm probably using, does everyone know what vectorizing something means? Raise your hand if you don't, I guess. Okay, great.
50-50.
I'm gonna give you the dumbest explanation of what vectorizing is. No one be mad at me. Vectorizing is basically taking a set of text and turning it in to some series of numbers with an algorithm, okay? So and it's multi-dimensional, and there's lots of how there's 3D, right? And it's there's length, width, and height. Well, now there's other dimensions, and there's lots of other dimensions, and you can't even fathom it because you're not a machine learning or engineer or data scientist, and you don't really need to. All you need to do is use the same algorithm on your source text that you use for your text coming in. And then you compare those vectors, and if they're close, they're similar. How similar? Who knows? But it depends on your chunk size, right? So experiment with your chunk size, experiment with all the different source data that you have, and you end up pulling 2 to 3 examples of known bad that are most similar to your source code set, and then pipe that in at the beginning into, because your LLM calls here, how do we actually do this? Where the fuck is it? Your actual prompt for this LLM is the instructions plus a new line plus the chunk. Well, what if you just add in the source data and say, is there a buffer overflow in this code base? Because you've already done the chunk, you've compared it, right? So you know that the closest similar examples to that chunk are a buffer overflow, a deserialization error, and blah, 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 blah. Well, just have 3 additional calls and then just compare those things and see if those things match up. And you can actually that's the next level of this, and that's what I couldn't get to because I had to rewrite everything. But you find output that is, let's see, I have to suspend the disbelief again, but let me, let's just do this window. Glue, dataset, JSON. Let's pull it back up. So when you build all that, it looks like when you get your formatting right in Markdown, in code snippets, in things like that, with a RAG pipeline, this is what you get as an output. And so this is our demo files. This is actually this is that code compiled and then decompiled using a decompiler and run through on the decompiled pseudo C. And so it strips all the symbols and everything the same, we did all that, but and so it gives you a code description because that's how we built it in, right? This is an LLM call. Summarize this code and tell me what it does. Then here's the code snippet. This function allocates memory. Oh, I fucked it up. Allocates memory, rewriting. It can add in a, hey, LLM, estimate a CVSS score based off stuff. I don't know. No pointer dereference, blah, blah, blah. I mean, it gets pretty cool. And this, I wish that I could have reconstructed it and you could have seen it, but at the end of the day, you're just watching it pull the source data. And so like it's not really like that cool. But the bottom line is that there's a chunk, it's got vulnerable code in it, and you're comparing that to known vulnerable things with a vector search. As at the baseline, easiest thing is just like quick vector math, and then throwing that into an LLM and saying how similar are these things? Is it real? Then you can get into even crazier stuff, where you take the code snippet and compare that to a known bad and a known good, and figure out which one it is closer to, a vulnerable pattern or a truly secure pattern. And then based off that, you can eliminate the false positives that the LLM's detecting. So let's circle back. So we got some lessons learned. This is more for like lessons learned on the last like 2 years of work, right? And LLM development, and like it's a lot easier for me to stand here and say this now because we know a lot more about like vector databases and stuff like that. Like I didn't know a lot about this when I started, and man, like vector database existed, but like machine learning people were the only people who knew about this stuff. Now you can go on YouTube and be like, I think even Cloudflare has like a RAG pipeline that auto indexes everything and does the search for you and like all the stuff, and like has a chatbot. Like you could use that to find vulnerabilities if you just uploaded all your source code as separate files. That would be a super cool project and not have to do any of the coding yourself. But the math doesn't always matter, because if you sit down and do true analysis on the best LLM and context window, and it's like 8B, like billion parameters versus like 30 billion parameters and blah, blah, blah. And then at the end of the day, it still gives you garbage output. It's not helpful. And so move away from that, and don't be afraid to be like a true hacker, hence the hacker movie, right? Just try shit. Because we did this by like, how do we know what the best chunking window is? Well, when you host your own LLM, I can run 100 experiments and just see which ones are better. And based off JavaScript, we know that the chunking is generally like this, but we can tune that based off of like whatever your code base is if you wanted to. Chunk size matters, difference between languages. You're looking for an LLM, like try it on Gemini. This is just ChatGPT. Try it on Gemini. We actually found really good luck with Llama. Llama 3.5 or something for some things, but then moved back to like a super dumb model. And we'll get into the next slide, like a more advanced search instead of just like a RAG pipeline. The source data, RAG or otherwise, can overcome limitations in what the LLM has been trained on. And so when you're building LLM type things, not just in vulnerability detection, but in your own work, don't be afraid. If you're already augmenting that data with the source data that you want, if you need better efficiency, don't be afraid of using a dumber model that's faster, because you might get better performance. LLMs at scale are a balance of processing power and capability versus time and expense in running it. Find the lowest capable LLM that gives results, and then continue to test over time. LLMs alone aren't the best way to detect vulnerabilities. I think that's like pretty obvious. Regex sucks. So, next steps.
One second. Sorry.
Yeah.
Where are your biggest challenges with this so far? Before we get on to your next
Scaling. Scaling the LLM calls based off a code base. Like, so we were cyber nerds. We were pitching to government, and we were trying to like, because we were like running stuff for like ODA detection. We were trying to like find how, like there was a AIXCC that they were running like a competition to open source stuff for like, and then you had to open source your model, and we're like, no, thank you, because it like you actually can find ODAs. But also, what's wild about this concept is training a new language is as simple as uploading a new database of known bad vulnerabilities. So we were able to train it really quickly on blockchain and Solana, yeah. And so like there's a inherent vulnerability in a bunch of blockchain protocols that can allow denial of service and things like that. And like we submitted bug bounties, and they're like, oh, that's not reachable. And then like the silent patch comes out, right? The next time when it gets like migrated in, you're like, okay, cool. So you just don't give a shit. Like, which is fine because it's still getting secured, but like you can easily train new languages with just source data. Scaling and running LLMs predictably and at scale is fucking brutal. And when you run your own LLMs, you run into the same DevOps concerns that you do for every other server environment in auto-scaling, except now you're at the whims of NVIDIA GPU, like CUDA core kernel calls and Docker containers, and are you passing through the right assignments and like stuff like that. Because I have a absolutely fully, in theory, functional T4 instance running in Azure that has all the correct stuff, and the damn container won't connect to the GPU, right? So like, how do you do that? Like you run into problems that are just so obscure because complex system, like in Azure, on their GPU, I don't know, man. Like, you know, and so even hosting your own on bare metal, like we've gone back to like on-prem shit, kind of a lot of the time. And like I can do things on a MacBook Pro now that are rivaling like the stuff that's happening in the cloud because we're using a much smaller model and using much more other machine learning tricks and techniques that the data scientists and machine learning people be like, yeah, why wouldn't you fucking do that? But all the rest of us are like, oh, I've never heard of that. I don't know how to do that type of thing. And so like learning that was also really hard. Sorry, that was a long answer.
Thank you.
But the next step, so like how do you make this better? And this is kind of like where we go, well, we rewrote it in Go, but that's different. Vector similarity for chunks run through similarity analysis using a vector database is like the next level. So like a vector database is super cool. You basically turn it into a number and then you search for the closest thing. He was talking about k-means and like clustering and things like that. And you can find the most similar versions of that is basically what's happening. So like that imaginary number is here, and all of the imaginary numbers that you've pre-plotted before in searches are all like around it. Well, what if there's one like right there? It's super close. It's probably like that one, right? So now you can use that as source data. Well, you're still doing a vector search and you're still relying on an additional piece of technology. And when you get new data, you still have to like recompute things, and that's fine, but like you're still making an additional call. So from a, we'll say production level standpoint, like that little bit can be a pain because it's introducing another place of failure, another level of like complexity. And so the next level of that is like kind of a neural net, which is like really all it was a neural net trained on all of the vectors. And like then just rapidly doing a quick match that spits out the actual source key in like milliseconds without having to do an additional thing if you've loaded it into the actual like container that you're running in. And because it's so fast, now you can kick off the threads for, oh, now you have the source data, the lookups for all the rest of it, the chunks, all those other pieces. And then each of those problems is just a small discrete problem that thread is just going to complete and add back into some type of memory safe container for that data. LLM selection, experiment as new models come out, old models get cheaper, GPUs get more powerful. I mean, shit. Like ChatGPT 4.0 mini didn't exist a year and a half ago, right? But now it's like the cheapest, most performant model that's being run for all of this stuff. And so like, yeah, as Llama 5 comes out, run Llama 5, see if that changes things. Run Llama 5 Nano, see if that does better results. Because at the end of the day, you can start tweaking your processes to get the best results because, again, just start hacking shit. Self-hosting LLMs, it's super easy. And if you're running a smaller LLM, it's actually like pretty performant. Like maybe not the multi-threaded space, but like then you can upgrade to an actual like multi-core GPU instance in the cloud. And if you're running like a smaller model, it's actually like much faster than ChatGPT is. LLM generated source data. Does synthetic data work for this type of prompting? Like, just raise your hand if you don't know what synthetic data is or the problem with it. Okay, everyone else keep me honest then. Synthetic data is a problem that you run into when we have trained LLMs on source data that's from like real people. But if you use an LLM to generate training data, it doesn't work. For whatever reason, like synthetic data isn't great for training and fine tuning things. So in this case, do we care about that? If you wanted to spit out 100 examples of a buffer overflow and just crank up the creativity to 1, would that source data be worthwhile in this instance? And the answer is yes. And so you can dynamically create examples because it's not, that's not what the LLM's doing. The LLM is just doing pattern matching. What you are doing is generating actual exploitable code snippets and using that to further refine your hunting and things like that. So like now at the same time, you're still relying on the source data, right? So like, does ChatGPT know how to make a vulnerability for denial of service in Solana? Probably not, right? Like for complex problems, you still need like a good know-how and someone to make that source data for you. But like, that's a problem that's achievable, you know? Like that's way better. Like we have LLMs, like it's pretty, that's the hard part. So once you solve the vulnerability discovery problem, do similar methods work for other things? What if you now want to fix the vulnerability? What if you want to write an exploit for the vulnerability? What if you want to write 100 exploits for the vulnerability and then run it through a test harness to see if it's actually exploitable and then have 10 different proofs of concept for an O-day immediately, right? So like, that's pretty wild that concept, like that is a realistic thing that could happen. And that's both scary and cool, I guess, right? So like,
Well, wouldn't we see all these LLM generated 0-day vulnerabilities, and has there been an increase in people finding them? And
I don't know, to see what comes. And so like, I meant this like truly as an academic question, right? Like if you continue this problem down the road, can you combine generated exploits into a test harness for exploitation validation? Not just one, but like, hey, find me a series of vulnerabilities in this program, do semantic analysis and code pathing, because all those problems are normal computing problems. Build a call tree and find where that function is for that call and find like every other function that calls that and then trace that back. That's like a processing problem. That's been solved. Like we could do that in Python right now.
Or even bigger, has anybody checked Copilot's generation or other tools like that to see if they're introducing vulnerabilities?
They are. And so that goes back to the source code thing. Like as we start developing more code with AI and large language models, I don't mean this as like, don't use AI. Like I can like half the shit was ChatGPT because I was in a bind in a hurry. But like, we are at the mercy of the data that's trained on that. And so you do need to like, maybe it's the stuff I built, maybe it's something else, maybe it's Sneak talking about like, oh, I got you. Like maybe it's Sneak saying, oh, we use AI now, maybe, I don't know. But like automated vulnerability exploitation based off like a decompiled binary is in the realm of possible right now. Like with enough time, like you could just take everything that I just talked about, all the things in this presentation, and like code it yourself. You'd have to work through the same now I still didn't talk about chunk size, the actual breakdown, like how are you doing the path tracing for those function calls? How are you doing the rest of the stuff? Like there's still a lot of problems to solve and you need a lot of creativity, but like, have we ever been this close before? Probably not. What was your question or comment? Okay, no worries.
I'm imagining all the North Korean hackers working on something like this.
Right.
Are you concerned about uploading your code to ChatGPT and that somebody else can see it at the other end or anything?
No, I'm not.
I mean, are you keeping everything in-house or are you sending anything up to the...
So I'll just say like, so I'll take off my, like developer hat and like the cybersecurity consultant that does this stuff and like has this conversation a lot. It's a data problem. This is like it's kind of an accusatory statement, but like if you're not already tagging your proprietary data as proprietary when all the rest of your organization uses it and sends it through email and uploads it to Box and puts it all the rest of the stuff? Are you really worried about, like, you don't have the ability to be worried about ChatGPT? Because the question should be, do you trust OpenAI as an organization to uphold their privacy policy? Do you trust Microsoft to uphold their privacy policy?
Yeah.
Right? Like, and so like your level of risk becomes where I want to host these LLMs if I want the benefit. Do I just want to run it on a Hugging Face open endpoint? Like, probably not, because then they are probably intercepting stuff, not in a bad way, but like you're not going to get a data leak from the LLM. You're going to get a data leak from all the supporting systems that are around it, or the controls that we're trying to put on top of the LLM, like Copilot, with access for like the poor man's RAG pipeline where it like answers questions based off your source data. That's not a problem with the LLM. That's a problem with the controls that have been put in place on top of the LLM for data. So I'm very opinionated about that.
It makes me think of the subpoenas that are coming down the road for IP theft that all of these
Oh yeah.
LLMs are going to face, and Discovery could reveal every chat.
I mean, then I don't think so. Like, it depends on, like, we have seen, like, let's look at the real stuff, right? So there was actually a preservation order that was issued. I can't remember, maybe it was to OpenAI, maybe it was to someone else, but like, there was a preservation order that said you are going to retain all of your chats from this point forward, because OpenAI straight up told them, we don't. Like, that's not in line with our privacy policy. We delete them after a certain period of time. And that comes back to how much due diligence are you doing on your vendors that hold the rest of your data, for how much they do data retention controls. Do they actually delete all your company's shit when you're done with the engagement? Like, no, they don't. I promise.
They mark a flag and say like, soft deleted, you know.
Right? And so, but how many email archiving tools? How many backups do you have that are immutable? How far do they go back? Right? So like,
Well, that's one of the reasons why a lot of places don't do long-term backups, because
yes.
even if you shouldn't have it, if you do have it, it's not just that the court can say you can't delete it now, but they can now say you have to go through every single byte of that as part of the stuff.
And so what you're getting into is the real world ramifications of the data problem. And this is something that, like, I mean, I don't mean this, again, I'm like trying to be a dick, but I say like a lot of mean things, but like, software developers have never given a shit, because frankly, they don't need to, right? Like, you don't care. You're writing code, right? Like, you're not touching sensitive emails. Like, you're not touching stuff that's like legally privileged, that has to do with PII, unless it's like in a database somewhere, in which case you probably have like a PAN solution to do that. But like, the enterprises as a whole have gotten away with just retaining all this data in the file shares and SharePoint, and just like sits there. And now Copilot is able to access all that shit and can actually find all the stuff that you weren't supposed to be holding in the first place. And so like, those preservation orders and discovery, legal discovery and stuff, like, that's why everyone's like, oh, why do I have a data retention policy? It's blah, blah, blah. It's so you keep your company out of trouble. Because if you're actually keeping that employee's emails from 10 years ago for that sexual harassment claim, like, guess what? It's in discovery now. And what was the statute of limitations? Your lawyer probably cares, but like, we don't, right? So like, we're spanning into the rest of the business conversations and the data, like sovereignty and residency and retention stuff that like we've never really cared about before, because now we have really easy access to actually process all that data.
So, are you starting when you're analyzing your code? Are you starting with the LLM model and then going over to things like code tracking, or actually running the code, or are you actually starting somewhere else? Because it seems to me like if you actually had a tool that ran the code one line at a time, and then ran the LLM against that, or maybe one function at a time, then you'd have your chunking already done, because you're only doing a small bit of code at that point.
Yeah,
you
so
don't need to chunk the whole
the
thing.
progressive nature of Git allows you to solve that problem pretty well. And so like, instead of doing full files, you can just do the diffs. or and then like maybe, you know, once every night you run it all the files that got changed just to catch the extra stuff or something. We did have a beta of like, we were looking into all the things you'd expect, right? Like VS Code has semantic highlighting, and there's like a whole engine for how you do code, not predicted text, but that type of stuff. And so you can, yes, thank you. And so like I was learning about that stuff because like you could run this against just like the predictive in like Copilot from GitHub. You could run this in your editor and it could tell you and flag, hey, this is a vulnerability while you're writing code. And it just becomes a problem of how much you want to, like once you solve the chunking stuff, right? There's like whole companies that are trying to solve that. But like there are ways to do it. And I think that like the market is ripe for that type of stuff. I think Cursor and Windsurf have like a lead on, and then we get into conversation about like VC versus bootstrapping and like how you do that type of stuff in the business side, but that's probably it's like a beer conversation.
Wasn't there some service like LXR that was actually doing the parsing of the source code repositories and like tokenizing of that stuff?
If it's public, you can scan it.
Not anymore. I was surprised that it disappeared.
Oh,
It
interesting.
was one of the Google's tools.
Oh,
That was doing those things on the
probably
source
sold to the
code.
government. They're like, we want this, thanks.
Yeah, it was that it was indexing like the Linux kernel, like whole source code. You were able to do queries, and it had more semantic queries that you were able to look for.
Turn this off.
Stop loops and stuff. That it was able to abstract out like the variable names and stuff like that.
Yep. Well, I mean, yeah.
Yeah.
So, I mean, this gets crazy because you can do this on assembly. And that's like the wildest use case from this is like you can decompile any binary and run this type of tool on assembly and vulnerable code snippets in assembly. And that's wild, right? Like, it doesn't matter which language is written in now, right? Like, it matters some of the stuff for like how the compiler built some of those calls and stuff, but like eventually you've got them all, and it's like, okay, now we just know how to do this. Yeah.
Better hope GCC is secure.
Yeah.
Did you, so in your like product, that you have a product, right?
Yep.
Okay.
I've exited the thing. Our IP got sold to somebody, and I stepped
Okay.
back to do.
Did you end up using a custom model, or was it really just piggybacking or RAGApp on top of?
Just piggybacking on a commercial model.
Okay.
Yep. And we had there were a couple that we experimented with. I won't give the true keys to the castle, but there's like a couple that are like surprisingly good at it, and that's like we only found that because we just ran. It's like, okay, what are the top models, or what are the first top 25 models on Hugging Face, and run a test group through like throw that test file through it, like just run, and then all the ones that are terrible, just okay, because they either come out garbage or you're like, oh, interesting. I wonder if I can refine this, and you got 3 or 4 that work. And then it turns out some of those are self-hostable. And then it's just like a regular development problem of how do I scale GPU-based resources.
And then when you compile and decompile, in theory, it doesn't matter what language, but now you're getting into the weeds of like what the where is the vulnerability in the language you're using or the code you wrote, you know?
Yeah.
Like if it was a compiled Python, let's
Or is
say.
it in the
Now,
compiler?
you
So
might
that's
need
like-
Exactly.
Python.
What part of the stack is it? Like,
Yeah,
there's
exactly. Because
100%.
Because people need to stay in their lane, and obviously you want to know what's there. But now what line is it on? Right now you're talking about where are you doing your own code or the vendors, whatever came.
The secret is
Upstream, yeah.
that you output a bunch of lines above and below, and then you search for that whole chunk in the find replace stuff, and then you'll find it.
Yeah.
So, one thing I wanted to mention before we run out of time here, if you look at like tuning a model, or instead of searching for the best model, taking a model and tuning it to be better at this, there is an open source project to help do that.
Mhm.
So I don't know if you're aware of instructlab.ai.
Yeah, so we decided not to fine tune because we wouldn't be able to as easily add languages or new exploits or bad code.
So what InstructLab does, and this is something I had to learn when I was working at Red Hat. So it's open source. You define in a defined taxonomy of skills and knowledge specific information you're going to give the model. So you write a YAML file that has a context and 5 questions under that context. And you usually submit 3 contexts and 15 questions. It synthetically generates data based on the information you've given it, and then uses that to tune the model. So it's almost like an existing model is an ice cream cone, and now you're putting the sprinkles on it for what your knowledge is or what your experience is. And then you can use this locally if you want. You'll have, like, you give it some LLM, and then you get like LLM Prime out the back end that you can use just yourself. If you like what you did or you think it's worth sharing, you can do a pull request to instructlab.ai. They will look at what you're doing, if it fits within the taxonomy, and if it's good, it goes into the next generation of IBM's Granite model. So they will incorporate it into their LLM.
Yeah, I would never do that for this because I would never want IBM to have the source code for all vulnerabilities. How much do you trust IBM?
Right. Well, I mean, you can
Doesn't matter, they won't do anything good with it anyway.
You can keep it on-prem if you want, but the interesting thing about that is that when you tune that model, it can unlock information that was in that model already. It just wasn't weighted to the point where it was being
it's
emitted.
reweighting it.
So you're reweighting it at the tuning phase of the model to make those things more obvious.
Yeah.
So it's a little better than RAG.
Like very practical use case for fine tuning. Or if you have this case where it's like, well, we can't fine tune because we want to like rely on vector